all of that. So we're going to create a directory, and we're just going to call it GraphQL test, or you can call it whatever you want. Now we should have 2 directories, right? GraphQL test or workshop, or if you did it somewhere else where you have more directories, that's completely fine. Now we're going to change directories into the GraphQL test. Being there, this should be an empty folder. So if you recall from in the last workshop that we had, I did pass a flag called -y, which I told you was yes. Essentially, that was going to answer all the following questions. This time, just to show you a little bit of contrast, right? We're not going to pass in the flag. So we're going to do npm init, press enter. And right down here, it's going to ask us for a package name, GraphQL test. It's going to grab it from the parent directory. Now it's going to be version 1.00. The description, which is going to be GraphQL server test. You can put whatever you want. You can leave it blank. I'm just doing this to show you. Entry point, index.js, test command. We're going to leave that clear right now. Get repository as well. Keywords, author, you can put your name. I'm just going to put Alejandro. License. By the way, none of that is required. You can leave it empty if you want. Then, is this okay? Yes. Second thing we're going to do is we're going to initialize our Git repository. So we're going to do git init, and it's going to be initialized. So because I just started one here, I'm just going to go ahead and copy this. You don't need to follow this, but again, I'm just kind of walking you through my steps. At this point, for me, this is natural. Like, this is a habit to do. I'm just going to git remote. I'm going to do git remote -v, and my remote is there. Now we're going to do, if we do ls, we list our directories, we should have a package.json file. We could look at that package.json file by saying cat package.json. And you're going to see, well, we have the contents, GraphQL test, the description I put in, right? And this is what's going to be in your package.json file. Now we're going to create another folder, again, because it's a file, I'm sorry. Again, I do this from the very beginning because it's bit me in the butt too many times where I've accidentally committed node modules. And at that point, I'm the kind of person that I actually just prefer to delete the repository and start over again because it's very annoying. So we're going to do touch git ignore. And now we're going to do code dot. So we're going to bring up our code. And let me bring this into the screen. Let me put it here so it looks nice for y'all. And we're going to have a git ignore. And the git ignore, first things we're going to do, even if we don't have it yet, we're going to put node modules here. We're also going to, our build directory is going to be called dist. And we're just going to call it dist here. Now, if you do control tilde, that's going to bring up your terminal in here. And we are going to now do, you can either go to here and do a left click and add a new folder. I like to do it from the terminal. So we're going to do make dir. We're going to create a folder called source. Then inside of that folder, you might have guessed it, we're going to call a file called index.ts. We're going to use TypeScript. Don't worry, this is not going to be that overwhelming. We're just going to use basic TypeScript, but just follow ahead and you'll see in a second. Now that we have this folder, so because I'm all about productivity, you might have heard me all the time say this is a productivity booster. I like to do Command P when navigating files. So Command P or Control P in Windows will bring you up a way to search up your files. So if we type in, and it has autocomplete. So now we're gonna say console.log and we're gonna say hello from index. Now we're gonna switch back to our console and we're gonna say node, yes, we're using node, and we're gonna do index.ts. And there we go. It's working perfectly. So far, is everyone so far okay? If there's any questions, feel free to just raise your voice and we'll address it, right? If you feel you're left behind, also, please feel free to say, hey, Alejandro, could you repeat this? Like, if you don't tell me, I won't be able to know. So yeah, perfect. Let me get a little bit of water. Now we're gonna install a couple of packages as dev dependencies, right? Because these are gonna be things that are gonna work in our development environment. So now we're gonna say npm install -d as a dev dependency, TypeScript. Now we also have to install some basic types for packages, right? And one, because we're gonna use Express, Express does not come with types right out of the box, nor does Node or GraphQL. So just thinking ahead, we're gonna install those. So we're gonna say at types. So that means that this all live in the types repository. Then we're gonna do types node and at types GraphQL. So again, we're installing npm install -dev dependency TypeScript, types express, types node, and types GraphQL, right? When we get to this, that was actually very fast. We're gonna go back to our terminal if it's already completed for you, and we're just gonna do touch tsconfig.json. So whenever you're creating a TypeScript project, you need to specify kind of sort of the rules. Just like when ESLint or Webpack, we needed to specify like the rules for this, we're also gonna provide tsconfig.json, which is gonna explicitly tell our TypeScript compiler what rules it has to work by. So I actually have one that I've been using for a while. So one thing you guys are gonna notice, and this is completely fine, is that I'm gonna paste this in the chat. So feel free to grab it from the chat. It's in the chat, I pasted a big JSON object. Just copy it and paste it in your tsconfig.json. And we're gonna go a little bit about what these rules are. So if you see, right, while you're copying it, I'm gonna tell you a little bit about what compiler is. So tsconfig.json essentially declares the compiler rules, right? So we could see no implicit any, meaning that we don't wanna leave any like things that are any, we want to, if a string is type string, we're not gonna like, we need to pass it the type string because if not, it's gonna have an implicit any and we wanna avoid that kind of thing. Strict no checks, no unused locals, no implicit returns. Then the libraries we wanna use, the modules, the target, which we wanted to compile to, right? And then we're gonna tell it, we want you, when you compile, we want you to exclude the node modules and we want you to include all the files that are either, that live in the source directory that are either .tsx or .ts. Is there any questions about the tsconfig right now so far? Cool, I'll take that as a no. So now we're gonna install a couple more packages. So feel free to bring up your terminal, go to the index.js file, and we're gonna install first npm id, and we're gonna do tsnode. Tsnode is think of tsnode as our engine or a runtime to run our TypeScript files, right? So how do we see this work, right? We can go to our node modules, and in our node modules, first of all, let's see, we have at types, and these are, if you notice, we didn't install all these types, but some come with TypeScript already. So they're or with like Apollo Express or something like that we installed. Others just come by default with TypeScript. And then we're gonna have in our bin folder, we have tsnode, tsnode script, and tsc, which is the TypeScript compiler. So now in our terminal, we're gonna say node modules. So node modules /bin /ts-node, and we're gonna say source index.ts. And boom, it compiled it using the compiler options that we gave it in the tsconfig.json, and it just put them out there. So what we're gonna do now is that, obviously, can you imagine having to write this node modules.bin every single time? That's pretty annoying. There must be a better way. And of course, as in coding, there is always another way. So we're gonna head back to our package JSON, and we're gonna create another script here. And this script is gonna be called start. And in our package JSON, we're gonna call this script start, and we're gonna say tsnode. And by the way, little known fact, you can actually abbreviate this as tsnd, but if you're working with teammates, I'm pretty sure they won't know what that is. So tsnode is a little bit more self-explanatory in my view. So we're gonna say tsnode src index.ts. So once you have that, we're going to switch back to our terminal and we're going to do npm start or npm run start. And there we go. It's working. Beautiful. Now, so when we were doing the React workshop, right, we had to do a lot before we actually got to React. Surprise, we're actually getting into GraphQL right away because this is all we need right now to start a GraphQL project with Express and with TypeScript. We've done everything we needed at the beginning. Now let's get into some of the action, right? So, by the way, I think that GraphQL rekindled my love with the backend. The reason why I'm starting to become a little bit of a more full stack engineer, like I have a project and I'll show it to you guys later, where I've literally built a full stack app with everything. The client is React, the API is GraphQL, the databases is in Postgres, and I was able to do this backend because I've been doing GraphQL for about 3 years, and I don't know, I've just loved it. It just feels like a natural extension to React. And you'll see why once we plug it in, right? So now we're gonna say npm install Apollo with 2 L's -server -express. Then we're gonna do express, so separate, another word. And then we're gonna do GraphQL -tools, right? So first things first, Apollo server express is what we're gonna use to initialize our Apollo client. Express, you've used Express plenty of times. I know it because I've seen some of your projects. And then GraphQL tools is rather on the newer side, but it's composed of older, or not older, more used GraphQL tools that all live separately, and now they all live within the GraphQL repo, right? So one of them was GraphQL import. Another one was like GraphQL loaders and whatnot. So they all now kind of all came under the same roof and live together. So once this is ready installing, just go back to your index, clean your index out, delete everything, and we're gonna start off by just importing Express. So we're gonna say import Express from Express, and then we're gonna say import, open and close the curly braces. We're not gonna put anything there, and we're gonna say from Apollo server Express. Cool. So I'm going to tell you a little bit because it took me a little while to understand when we use curly braces and the imports and whatnot, right? So just as a refresher, I'm sure you all know, but if we do something like this, right, or Apollo, I mean, that means that we're importing a default. So you can export from a file in 2 ways. You can either export default, which you're exporting one thing, or you can do named exports, which is like const, let's say export const, I don't know, yo-yo, right? And when you export something as a name export, you can be specific when you import. So you could destructure it and you can essentially say, I want something specific from Apollo server express. However, if we were to do this, we would be getting the main export, so the default, which is importing one big object, and then we'd have to do like Apollo dot this and Apollo dot that, right? So we're gonna open our curly braces, and we're gonna say we want 2 things from Apollo server express. We want Apollo server, Apollo server, and then we're gonna import one called GQL. And you'll see what that does in a second, right? So first thing first, we're gonna create a constant, and this constant is going to be called start server. Then we're going to leave that empty. We're going to leave that scope and we're going to say start server. We're just going to invoke that function down here. So far, is everyone good? I'll take that as a yes. So if you recall earlier, I mentioned that the minimum requirements to start an Apollo server express is the schema, right? So what is the schema? To Apollo server express, the schema, and to GraphQL really, because it is a reflection of the GraphQL spec, the schema is composed of 2 things, the type definitions and the resolvers. This is the way I like to look at it. I'm sure the definition by the book is different, but this is what's kind of helped me understand it. The type definitions are sort of a documentation. They are sort of saying, all right, what the queries are going to be, what they're going to return, what they're going to take as arguments, if it's going to be a query or a mutation. And then the resolver is going to be sort of like the engine that executes those specs, right? So we're going to say, first of all, const server. We're going to create a const. And we're going to initialize the server. And we're going to call this Apollo server. We're going to pass in an argument. And into that argument, we're just going to leave it empty for right now. Then we're going to create const app. And we're going to initialize Express. So Express in this case is going to be the middleware. Now we're going to say server.apply middleware. And this is a function. So we're going to open a curly brace. And we're going to say first app. So this is the middleware that we want to apply, which app is Express. And then we're going to tell the path that we wanted to take, which is going to be GraphQL. And we'll talk a little bit more about this in a second. Then the new one that we're going to do is app.listen. So from the middleware. And this is going to take one argument first, which is going to be an object. And we're going to call that argument port. And we're going to set it to port 4000. The second argument that it takes is a callback. And here we use this to essentially notify, where we started, right? So we're going to say console.log. And we're going to open the template literals. And now at this point, it's just kind of habit for me, but we're going, I like to add the emoji, the rocket emoji here. I think I've read it in the documentation so many times that I just kind of started going with it. Now we're going to say server ready. And you don't have to do this by any chance, right? Server localhost 4000. And then we're going to interpolate. And we're going to grab our server right here. So we're going to say server dot GraphQL path. Sweet. So this is going to fail, but I want to show you what happens when we do npm run start. I told you it was going to fail. This is expected. No worries. So now it's going to fail first because, so this is one of the advantages of TypeScript that I really like. It says GQL is declared, but it's never read. So the compiler immediately breaks, right? Because we told it in our tsconfig JSON that we don't want any unused variables. So I'm pretty sure it's somewhere around here where it says no unused locals, no unused parameters, right? So it won't even compile. So that's one of the amazing benefits of TypeScript, right? That if you have an error, it won't let you compile it. So it gives you more of a confidence that you're working in a better environment, right? You don't have to follow this. I'm just gonna show you the error. Just gonna delete GQL. And now I'm gonna do npm run start again. And we have another error. And the error says Apollo server requires an existing schema. If you recall, a few minutes before I said, right, that the minimum requirements to get an Apollo server going is the schema, which is composed of the type definitions and the resolvers. Now that's what we're gonna jump in and do right now. So right above server, we're gonna say const type defs, which stands for type definitions. Now we're gonna go back to our import statement and we're just gonna import GQL. And we're gonna use GQL. So GQL is a function, but we're gonna use the same. If you went to my styled components workshop, you'll recall what the template literal syntax does. We're gonna use the same thing. And essentially what this syntax allows us to do is to pass in an argument, but in the string format, which will allow us to interpolate things, right? But most importantly, it'll allow us to stay truer to the GraphQL syntax. So we're gonna do type. We're gonna say query, uppercase query, open the parentheses, then we're gonna say hello, and we're gonna indicate that it's gonna return a string object, and the $sign indicates that that string object is required. So this was what I was mentioning earlier about the type definition. So if you see, it's really just a definition, right? It's just saying, okay, there's a type of query. When you hit hello, it's gonna return a string. It's not telling you what it's the specific about what it's gonna return. It's just gonna tell you the type that it's gonna return, right? Now we're gonna create our resolver. So we're gonna const this called resolver, and we're gonna open an object. And now we're gonna write query, uppercase query. We're gonna open an object again, press enter, and then we're gonna say hello, colon, and we're gonna make a callback here with a fat arrow. And this is just gonna say hello from resolver. Right. Now, we're gonna go to our Polo server and we're gonna pass two arguments, typedefs and resolver. Oops, resolvers. What is cannot, oops, my bad. Add a little bit of a, and then resolvers. There we go. Okay, so if you notice, I told you that the type definitions are sort of like the document, right? They're gonna document what the query or the mutation is, and they're gonna tell you what each one individually returns, right? The resolver is actually what's gonna execute it, what has the logic to execute it. However, just so you know up ahead, when there is a type definition, there has to be a resolver for it. There's a one-to-one relationship, right? So if you have a query called hello, you have to have a resolver called hello. If you have a type definition, which is a mutation, for example, called create user, you're gonna have to have a resolver mapped to that is also create user. I'm gonna show you what happens. I'm just gonna delete, it's this sensitive. I'm just gonna delete one letter and I'm gonna do npm start, right? And this is gonna give us an error right off the bat. It's gonna say, query.hello is defined in your resolver, but not in your schema. See? So you always have to have, per each one, you're gonna have to have another one. Then I'm just gonna go here and I'm gonna delete one from the query, one letter, just so it sees that there's like a difference, right? So now it says query.hello is defined in the resolver, but not in the schema. So I hope we got that point through, right? Is there any questions now? Does that answer the difference between like the type definition and the resolver?
Yeah, it's pretty clear.
Cool, glad to hear that. Let me kick that off again. And this time it's gonna say server ready at 4000.graphql, right? Because this is one of the differences with HTTP, right? When you have Express, you've probably done this. With Express, you basically have separate URL endpoints, right? With GraphQL, it's only one. You're always gonna hit one endpoint. However, that endpoint is gonna have queries and mutations and whatnot, right? So that's when you sync your Apollo, it's gonna know what is what. Now, I'm gonna take you quickly to the browser and we're gonna go and see what localhost 4000 is, right? So localhost 4000 is going to be here. And let me delete this. And let me introduce you to Playground. So if you've only used Express, and again, this is the way I like to see it and the way it helps me understand it, Playground is essentially the postman for GraphQL, right? So if you ever want to test a query out, you'll do it through this, right? And the cool thing is that this gives you an ability to interact with your API without having it to connect to the client. If you want to test out a query while you're development, you can use Playground. I use Playground all the time for everything, no questions asked. I love it. It's and the UI is just beautiful. Look at it. So I'm gonna show you around a little bit what Playground has in store for us, right? So on the left, we would write our queries or our mutations. On the right, if we hit play, it's gonna give us the return value. And then you're gonna see here on the left, we have two things. We're gonna have the docs and the schema. So one of the things that I haven't mentioned is that GraphQL is pretty much, so GraphQL wants to be predictable every single step of the way, right? GraphQL, and that's why you see that there has to be a one-to-one relationship between the query, the resolvers, and the type definitions, is because it wants to be predictable all the time. And because in order to help this to be predictable, it becomes self-documenting. It auto-generates its documents. So if we click here on docs, we're gonna see that, hey, our queries right there. So imagine if you have like 20 queries, all those queries are gonna appear here. Let's click into this query. This query is gonna tell you exactly what the return value is. and it's going to tell you, you know, the scalar. So in Postman, not that I know of, does not give you all this information, right? So if you want to see the arguments that you have to give to, let's say, the logging input or the logging endpoint in an HTTPS, right, you'd have to go to your code and see it. With this, it's all self-documenting, right? And the schema is just a more rougher view, but it's exactly. Yes, Juan, Playground does come with GraphQL. I mean, it comes with Apollo server out of the box. If not, you would have to install it, but Apollo server gives us that right out of the box. Does that answer your question? Cool. So now we're gonna say, here is gonna show us our scalars and whatnot, our type and query. So let's test this out. So just so you know, you would have to do query, and then we would do hello. Then we're gonna hit play, and it's gonna return us. So this is what it would return to the client, right? This is the payload on the side. Just so you know, when it is a query, you don't need to pass that it is a query. So this would work. If you don't pass, if it's a query or a mutation, it'll default to a query. A mutation is in general when you want to, let's say, mutate the database. So the spec doesn't really tell you or define the difference between both the query and mutations, but this is the way I like to think about it, right? Because technically, you could use a query for mutations, really. But in general, this is how I've learned it from the very get-go. And all the documentation seems to point at this as well, and all the various tutorials I've done, right? So what queries, the way I like to think about queries are just gets. Whenever you need to do a get request through HTTP, that's a query. Get user by ID, anything like that would fall under the query, under the convention, right? Now, if you want to do a put, a post, a delete, any other of the CRUD operations, that would be a mutation. And I don't know, I kind of feel that in a sense, GraphQL is more intuitive than HTTP, because with HTTP, you have to worry about post and when to use a put and when to use a delete. But with GraphQL, it's just either a query or a mutation. So rule of thumb, if you want to get anything from the API or from your database, use a query. If you want to mutate, the word says it, you use a mutation, right? So think about it that way. Although you could technically use a query for a mutation, they would literally, it works, I've done it. And there is no clear definition about that. Is there any questions so far about that? There's gotta be at least one question.
I don't know, man, you're pretty straightforward.
All right, I appreciate that.
I mean, it's
right.
different when you type it up, but no, it seems pretty like clear and the way you're explaining it.
Okay, cool.
This is really cool.
What are your impressions, Juan, of Playground? I know you asked a little bit about it.
No, this is awesome. I don't like Postman. I use a VS Code extension for HTTP requests, but this is awesome.
And you said you could use this with, like if we were working with like the MERN stack, if we were doing HTTP stuff, like we can use this in place of Postman, or is it specifically
no.
just GraphQL?
This is for GraphQL, and well, at least I only know how to use it for GraphQL. And if I believe its predecessor was called GraphQL or GraphQL. Mm-hmm. But yes, as far as I know, this is only for GraphQL.
Okay.
Cool. Now we've gotten into a point essentially where we've got our thing going right and everything. However, we forgot something. Let's just install our NPM, our ESLint, right? Last time we configured it from scratch. This time we're gonna use the CLI tool to do it for us. So we're gonna do npx, if you don't have it installed globally, ESLint -- init. And we're not gonna give it any flag. We're just gonna go through the questions. And the reason why I wanna use it this time is because I wanna show you both contrasts, right? In one workshop, in part one, we went through what it was installing like from scratch. Now for this one, let's just go through a CLI, and I want to go through the questions. So you see, by the way, once you've gathered experience, configured ESLint, it's actually a waste of time to configure it. And just so you know, I actually have my ESLint configuration saved in my Git, and I just go, every time I start a project, I just literally copy it and paste it. I've kind of refined it through time, but it's not something I do every single time. If you're doing it, you're killing precious time that you could be doing other things, right? But if you don't want to do that, if you don't want to copy it, you could do npm ESLint init. So first question, it's going to ask us 3 questions, but we wanted to check our syntax and to find problems, right? That's the point of ESLint. But we could also just check syntax only, or we could also tell it to enforce the code. However, for today, we're just going to do check syntax and find problems. Second, it's going to ask us if we want to use JavaScript modules or CommonJS. Obviously, JavaScript modules, import, export, right? Then it's going to ask us if we're using React or Vue. Because if we are, that means that we're using JSX or HTML combined in our JavaScript. So it needs to add packages in order to run that. But we're not using any of that, so we're going to put none of these. And then it's going to ask us if we're using TypeScript. It's that freaking smart. And we're going to say yes. Now it's going to ask us if we want it to run in the browser and Node in the browser. Then it's going to ask us, so this means what format do we want it? If we want our .ESLint RC to be in a JSON format, a YAML format, or a JavaScript. If you recall from my first workshop, I actually like JSON better. I personally feel that it gives me more autocomplete, better IntelliSense. And then it's going to ask us if we want to install these packages. So because we told it that we're going to be using TypeScript, it said, okay, because you're going to be using TypeScript, you need to install the parser, you need to install the plugin, and you got to install the latest of ESLint. Are you cool with that? Yes, please install it for us. We don't want to worry about that this time around, right? So that's going to be installing that. And what you're going to notice right here, first of all, it's installing all the NPM packages. But we're, in the meantime, let's create a file. And we're going to create a file called prettier RC. We're not going to do anything right now. We're just going to leave it there, prettier RC. And now that the ESLint is created, let's go to our ESLint file and look everything that it did for us. We didn't have to do anything of it. It configured it all for us. Browser true, it extends ESLint recommended, but it also extends the recommended for TypeScript, which is pretty dope. Before, a couple of years back, ESLint didn't have TypeScript support. You would actually have to import another library called TSLint. And now they adopted TypeScript, which is the most awesome thing ever. And we can see, the parser options, and the plugins. However, because we want this to run with our ESLint, we're going to install with our prettier, we wanted to install 2 more packages. First of all, we're going to do npmi-d as a dev dependency. And we're going to do prettier and ESLint-config-prettier. And if you recall, what this is going to do is that this is going to, first of all, install prettier, which is the code formatter. And then we're installing a package, which is called ESLint-config-prettier, which is essentially going to tell, hey, prettier is running. So if there's some rules in prettier that you don't want to abide to, let's make a contract and kind of let's just make sure that we work together fine, right? If you go to your browser and you go to prettier, right? And just go to prettier.io. And I'm gonna copy this into the chat. You don't even need to do this, but you go to Playground. We can choose what we want, right? And we're gonna tell it this time, parser TypeScript. So we're letting prettier know that's going to be in a TypeScript project. Semis, no, we want all that. And I'm not really going to mess with the rules. Right now, I'm just kind of getting something here. And we're going to do config JSON prettier. We're going to paste this in the chat. So it's in the chat. You can copy it directly from there. Also, if you recall, I had the abstract syntax tree. And this is just to show you, is essentially, this is, is the abstract syntax tree. The AST is what packages like Babel, ESLint use in order to be able to go through our code and essentially transform our code. So now head back to the prettier RC file, and in the prettier RC, just paste what we had copied, right? So we have, if you see arrow parens, obviously because we're not using Vue, it just sets it to files, the trailing commas, the tab width, semis, all of that, right? Now, if we go to our index and we delete this, and we do command save, it's going to put the semicolon back in. And if you recall, the reason why that happened is if we go to our settings, and you can either do command comma on Mac or control comma on Windows, and in the search bar you type format. Because we have the prettier extension installed, we have it selected here, and we have format on save. Every time we hit save, it's just gonna take our ESLint rules, our prettier rules, and it's gonna bundle them together, right? Sweet. Now that we have ESLint and everything, let me minimize this. We're gonna separate our type definitions out. Now we're gonna start scaling our project. So first things first, create a new file under folder and call it typedefs. Typedefs.js, .ts. I'm gonna rename that. And you might have guessed, we're gonna go to our index file. We're just gonna copy the type definitions, or you can cut them out, it doesn't matter. And we're gonna go to our type definitions, we're gonna paste this, then we're gonna export const. And because we don't have the GQL, we need to import it into this file. So we're gonna do import GQL. We only wanna grab the GQL package from, or function from Apollo server. And boom, just like that. So make sure you're importing the GQL and make sure that you copied over the type definitions. And then let's go to our index file. Let's delete this here. And let's say import typedefs from, and then we're importing them, right? From, so type definitions. So everything should be working. I did npm start, that's my abbreviation, my alias. And it should still be working. If we go to our playground, we're gonna refresh this, cool, still working. Now what we're gonna do is we're gonna separate out our resolvers. So cut your resolvers out and create a new file in source, and we're gonna call this resolvers.ts. Paste this and make sure we export it. So all we did was cut out the resolvers from our index file and carry them over to our resolvers file. And now we're gonna go back to index and we're gonna import resolvers from resolvers. Sweet. And let's kill our server, restart our server, and we should go back to our browser and this should be working. And it's working because it's not failing. We could refresh. And you know what? I always get annoyed that I have to kill my server and restart it every single time. There's gotta be a better way, and there is. We're gonna install a package called nodemon. You probably know what nodemon is. I learned it at Ironhack, so I'm pretty sure you guys are using this in your packages, in your Express. So we're gonna do npmi nodemon. Pretty simple. We're gonna go to our package.json file, and in our start script, we're gonna, at the very beginning, we're just gonna say nodemon -- exec. So essentially, what this is creating, right, is this is executing this file, and that is gonna be source index. So the content on package.js is newer. 1 second. Let me just go my package.js. Let's go, oh, that's, so do nodemon -exec. And before we move on, we're just gonna add another script right off the bat because I forgot about it, build. And what build is gonna do, so when you deploy your servers to, like, let's say Vercel or Docker or AWS, essentially Docker at one point in the Docker file, it's gonna, or in the bin, in the bash file, it's gonna build your project, right? And it's gonna output a folder, which we saw in React, we called it build, here we're gonna call it dist. And what that's gonna do is essentially Docker is gonna grab that build or whatever you're deploying it to, or the hosting service is gonna grab that output directory that we're gonna do and is gonna host it, right? So because I've deployed a few times with Docker, one of the commands that you give in your deploy scripts is that you have to install your dependencies, right? So you first install the dependencies, then you build it with the dependencies installed, and then you deploy it. So we're just gonna npmi it from the beginning, and then we're gonna say TSC, which is TypeScript compiler, which when we install TypeScript, that comes installed, and we're gonna say src, oh, sorry, we're gonna do out dir, so output directory, and we're gonna call this dist. Now we're gonna head back to our terminal, and we're gonna do npm run build. And if you see here, we're building this, and this is gonna output a directory. First, it installed our npmi, because that's what we're doing. It's a npmi, and then once you do npmi, you're gonna compile an auto directory to dist, right? So if you can see, all our files are there. However, something's missing here. Our TypeScript definitions are missing. So we're gonna go after TSC, we're gonna pass another flag. So in between TSC and auto directory, we're gonna do outdoor dir, we're gonna do now npm run build, and we're going to now, or we should see now at least, right? We're gonna see type definition here. See, our types, obviously because we haven't declared any types, right? But there it is. It's just building it now with our type definitions. And this is a TypeScript type definition, not the GraphQL type definitions. So now, I'll grab a little bit of water here.
Hey, wait,
Yeah.
Alejandro, I missed
Yeah.
what you installed. I missed the last thing you installed in the terminal. What was it?
NodeMon.
Oh, after did okay.
No,
thought you
I didn't
did
install
something.
anything. So this,
Oh, I missed that last part is what I'm saying.
Oh, okay. So when you do build, the build script is first gonna install the dependency. So anything that you have in package.json, so it's just gonna grab everything that you have here and it's gonna install it. So you're not installing anything. The build script is gonna do it for you.
All right,
And
yeah, I missed
then,
that part.
and then it's gonna grab everything and it's gonna compile it and output it to a directory called dist. Right? So does that make sense?
Yeah, I got it. Yeah.
Okay. So now head back to your index. We're gonna do in our terminal npm start. So now, first of all, you notice that, you know, it's changed right now. There's a little bit more here because this is NodeMon. You say now it's watching the path, it's watching the extensions that we're gonna use and whatnot. So this is what NodeMon's gonna give us, right? So if we go to a resolver, let's just say we're gonna change this value. Now we're gonna save this. It's gonna rebuild our package. And if we go back over to the browser, it's going to update it for us as well. So this is like essentially the hot reload when we're doing React, right? So up to this point, we've, actually, I don't know why I quit this. We're just gonna leave this running from now on because now it's gonna keep rebuilding. So at this point, you know, for me, it's kind of annoying to be using this syntax. This is not the GraphQL. Well, I mean, this is the GraphQL syntax for the queries and the types, but we have to wrap it in this GQL function every single time. There's gotta be a better way, and there is, right? First of all, we're gonna, if you recall earlier on, we installed a library called GraphQL Tools, right? So GraphQL Tools is gonna essentially allow us to import GraphQL type files. And we're gonna do that this way, right? We're gonna go, first of all, we're gonna rename our entire type defs. And you can call this whatever you want. We're just gonna call it schema.graphql. I love it, especially because I got this super dope icon and I'm like a geek for that type of thing. So, but this is like, wait, what the hell is going on here, right? And this didn't reload because it's only watching .ts and .json files. That's fine. Let's just delete this last line here and this lines, and let's just save. And this is more GraphQL, right? However, because we're not watching the .graphql files, if we do npm run start right now, it's gonna break, right? And it's gonna be like, yo, you're telling me I'm expecting something from typedefs. Typedefs is not there, of course. So we're gonna delete that. This is going to keep failing because now typedefs is not defined. So we're going to import 3 sub packages from GraphQL tool. So bear with me for a second, just follow along and we'll make sense of it in a second. So we're going to say import, open close curly braces, from, and then we're going to say at GraphQL dash tools / load. Now just select that, copy it, and just paste it. Oops, paste it. We're gonna import 3 things, right? So now we're gonna go to, and I'm just doing this because I'm too lazy to write it out. So the second one is gonna be GraphQL file loader, and the third one is gonna be schema. All right, just gonna give you a second to kind of sink in what we did. Essentially, we just wrote an import. We're not importing anything yet. And then we copied that import, we pasted it 2 more times, we changed load, and we just changed the package that we're tree shaking, right? So from the first line, on line 6, we're gonna import a package, a function called load schema sync. From the second one, we're gonna do, and watch out for the casing, GraphQL file loader should come out in your autocomplete. And then in the third one, we're gonna create one called add resolvers to schema. Now we're gonna import one final thing, and this is gonna be, we're just gonna import everything as path from path. So, but because this is a node thing, and if you recall, when we were doing it in the Webpack, we did const path required, right? Because this is node and everything, we have to, and because it's TypeScript, we have to import everything as path. However, we don't want everything from path. So we're just gonna destructure the join, right? So that means that from the path object, we only want join. So the first thing now, did everyone get this copied and everything? I hope so. The first thing we're gonna do is we're gonna define our schema. So we're gonna say const schema, and then we're gonna say load schema sync. So we're calling that function that we had, and then we're gonna create the path to where we wanna import that from. So it's actually join because we imported join. And then we're gonna say their name. Now we're gonna tell it the second thing is gonna be schema.graphql. So essentially GraphQL. So essentially, right, that's just gonna grab our absolute path and create a new path with schema GraphQL. So this is gonna know where to load the schema from. Then as a second argument, we're gonna pass an object here, and that object is gonna take a key called loaders, and it's gonna open an array because we can pass multiple loaders, but this time we're only gonna create one, and we're gonna say GraphQL file loader. We're gonna initialize that class, and now we've imported 3 libraries from GraphQL tools, which are all separate tools. And by the way, all these tools used to live separately before, but now they all, came together and live under the GraphQL tools repository. So now the second thing we're gonna do is we're gonna mesh our resolvers together. So again, I'm just reiterating. So if you recall, Apollo server requires one thing, a schema, right? And that schema is made out of our resolvers and our type definitions. So now, because we're using the GraphQL syntax and we're using the file extension, obviously JavaScript by JavaScript itself doesn't know how to interpret it. So we're adding all these packages to kind of make it work together, right? So the next thing, we've defined what our schema is gonna be. So we're loading the schema from our directory, and we're gonna use the GraphQL file loader to load that schema. And now we're gonna say const, we're gonna create a new constant. We're gonna say schema with resolvers. You can really literally call this whatever you want. And now we're gonna use the function called add resolvers to schema. And we're gonna open parentheses. We're gonna pass an object as an argument. And we're gonna say schema and resolvers. Cool. So now we're gonna move over to our server, just delete these 2 lines, And now if you notice, Apollo server is saying, okay, with Apollo server, we could do two things when you initialize it. We can either pass separately the type definitions in the resolvers, or we can create a schema and say schema with resolvers, which is essentially bundling our loaded schema with our resolvers. And then at it, we're gonna hit save. And voila, it's working. Let's go back to our playground and make sure that it's working. Seems to be working. If it's working, and there we go. Any questions so far?
No.
Okay, cool. Just to reiterate then what we did, I just reiterated, but what we did is essentially we converted our type definitions into a schema GraphQL file, which, I feel it's more syntaxy. I like to be more idiomatic about things. And then we separated our resolvers. Next, what we're gonna do is we're gonna start mocking out a login, right? So first things first, we're gonna go to our query and let's just delete what's in our query, right? And we're gonna call this login. And then we're gonna say that login, open parentheses, takes an email, which is of type string, and we're gonna say string is required. And it also takes a password, which is also of type string, which is required. And for right now, we're just gonna return a string. However, if you wanted to, you could do something like, obviously we could be like returns user, and we could be like type user is composed of an email, which is a string, and a password, which is a string. And right, this is basically when you start getting into like GraphQL, actually, we'll actually do this example in a bit, but I just wanted to show you. So that means that when you hit this, it's not required to return user, so you don't have to return anything. But if you return user, you could just get either the email or the password field, right? With HTTP, and this is one of the biggest difference I feel between GraphQL and HTTP. HTTP, so what we've regularly used before, is an all or nothing. You either get the whole object, so either you get the email and the password, or you get nothing. With GraphQL, we can decide whether we want only the email or we want only the password, right? And we'll get to that in a second, but we're gonna say string, and we're gonna create this. Because we're not watching our GraphQL files, we're just gonna rebuild this, and this is gonna fail right now. And the reason that this is gonna fail is that because if you recall, there has to be a one-to-one relationship. And now it's saying, hey, there's a query called hello, defined in our resolvers, but not in the schema. So let's go fix that. Let's go back to our resolvers. Let's delete this line right here. And let's say login. And then we're gonna open a fat arrow function, a callback, and we're just gonna leave curly braces. And now that we've actually gotten into this, I'm gonna tell you a little bit of the anatomy of the callback. So we're just gonna press enter. We're gonna return a string, and that string is gonna say login successful. So there's three things that we can get out of this argument. The first one, I've never used the first argument. I've never seen anyone use the first argument. And as convention is denoted, in 3 years of using GraphQL, I've never used the first argument. So as anything, when you don't use it, you're just gonna do an underscore, and we're gonna label this as any. Then the second argument is gonna be the arguments that your query provides. So if we go here, this is gonna be the second argument. So either you can destructure it or you can call args. We're gonna call it type any for right now. Actually, you know what? We're gonna create our first interface. We're gonna say interface, login arguments, and we're gonna say email is of type string, and password is of type string. Now we're gonna go here and we're gonna say logging arguments, right? So, and the third one, which we're not gonna use, is context. Context, just like in React, it is a global variable, and we use it to essentially pass things around our API, right? Most of the time, we could, if it was in a real application, I'd probably be passing my token in there, as we could leverage our authorization and authentication methods through context, but we're not going to use it right now. So we're going to say, we're just going to console.log args, right? Now we're going to save this, and this should rebuild, and this should rebuild fine. So now if we go to, so just to recap what we did here, we created an interface, which is basically going to be the definition for our arguments. So we're saying that our arguments have to be email and password, and they're going to be both of type string. Now let's switch over to our playground. And in our playground, if we go to our schema, this is updated for us. And now it's going to say, first of all, type user. It's going to take an email and a string. And we are not using the type, but you would see it reflected here because it is defined in our schema, right? So what you're seeing in your schema is exactly what you're going to see here. You could also look at the documentation, right? And that would show you the documentation. So let's go here and let's do login, email, just test, and then password, test, right? Now we're going to hit play. It says login successful. And if we go to our console, see, that's that second argument that we have here, right? So we could even take this a step further. Let's just destructure this. And we could do email. And look, because we defined what our arguments are, we get IntelliSense and autocomplete out of the box. So we could essentially, because we're telling TypeScript, because we're using TypeScript, right? That's one of the big powers of TypeScript, that it gives you this IntelliSense and this autocomplete path out of the box because we're defining the type that it is. So it is kind of like self-documenting, right? So you could go to interface and you could see what it is, right? So don't follow this. I'm just going to show you here. So if we do args here, if we go to our arguments, if we hover our arguments, it is going to tell us that it is of type logging interface. If this would be a type tool, which is also a valid way of doing it, we could see also, we could use tabs, and we could hover our args and our login arguments, and it will tell us what this type is defined of. So that's pretty powerful. I'm just going to go and destructure this again. Email, password, cool. Now that's going to break, and that's going to break because it's saying email and password. Cool. So now that we've done this, now we're going to do, because we're not connecting it to a database, right? We are going to pretend that we have a user and a password and everything. So let's walk through the login process, right? The login process, very basic, very nutshell, does three things, right? First of all, it is provided an email, so, and a password from the client. And what it's going to do first, it's going to go to the database. It's going to grab the email, go to the database, and say, hey, it's going to search for the email. If there is a match with that email, it goes to the next step. If not, it's going to throw an error saying, hey, user does not exist. I couldn't find it. Then it's going to go to the next step if it found the user, and it's going to look for the password. It's going to grab the password from the database. So found the user, it's going to grab the user object, and it's going to say, okay, user.password, is it the same as the provided password by the client? It is. Good. Here's a token. You're authenticated. Good job, right? If not, it's going to throw an error and say, hey, this user and this password do not match. I'm sorry, you're not authenticated. So first things first, we're going to imagine that we are connected to a database. So I'm just going to create a constant, and I'm going to say take email from DB. And we're going to say this test at test.com. Then we're going to create another constant, and we're going to fake password from DB. And we're going to say test. Cool. Before we continue, I'm going to add a package that's called bcrypt. You've probably used it. Bcrypt, we're going to use it to hash our passwords, to compare, and it's going to allow us to do a better encryption. So npm install bcrypt, and we need to install the types for bcrypt as well, because it doesn't come with TypeScript out of the box. So while that's installing, we just go back to our resolver file to the very top, and let's import everything as bcrypt from bcrypt by bcrypt. Just kidding. Okay, so now what we're gonna do, let's just change this here. We're just gonna imagine that we've hashed it and everything, right? Just gonna do bcrypt.hash, and we're just gonna give it the first argument, which is gonna be like, imagine that this was already from created, and we're gonna tell we want a 10 encryption. Now what we're gonna do is, okay, so imagine that it went and it found the email. So now we're gonna say, okay, if email, so if the provided email is not equal to the fake email from DB, we want you to throw an error, throw new error, and we're gonna pass it a string, right? So we're gonna say user with email does not exist. Cool. Well, oh, it's supposed to be uppercase E. Awesome. Now we're gonna say, right, let me close this. Now we're gonna create another one called a constant called valid. And this is where we're gonna validate the password. So we're gonna say bcrypt.compare. And again, we're gonna use the password that was provided, and imagine that it went to the database and it grabbed the password and it's gonna compare it. So this is gonna either, valid is gonna return a true or false. Now we're gonna do if not valid. That means that the password that it compared is not the same password as the stored password. We're gonna throw a new error, and we're just gonna say password and, or just email and password do not match. Email and password do not match. And reason this is security, right? You never want to just say, hey, password does not match, because then they know, hey, the email is correct, it's just a password. You're just giving them tips, right? And if everything goes well, oh, I have an error here. Let me just fake password from DB. And what is this saying? Oh, I forgot something very crucial. Bcrypt is a promise that needs to be awaited. So we're gonna, at the very beginning here, we're gonna make this an async function. And we're gonna say await bcrypt and await bcrypt, await bcrypt right here. Okay, so now everything should be fine. Let's go to our terminal, npm start. And while this is starting, I'm just gonna quickly walk you through what we're doing again, right? Imagine that we went through a database. This is a password that we have stored in a database and whatnot. First step, the client gives us an email. We're gonna check that email, and if we don't find it in the database, we're gonna return a new error saying, hey, user with the email does not exist. Correct. Then we're gonna create a function that's gonna take the provided password by the client, and the password, if the user exists with the email it was found, is gonna return us this user object, which is gonna have a password in it, and we're gonna compare that hash password with the provided password. And if that is not valid, it's gonna throw an error. But if it is valid, it's just gonna log in successful, and then in another scenario, it'll return the user and whatnot, right? So we're gonna go over to our Postman here, and it's gonna say user with email test does not exist. That's supposed to happen, right? And it's supposed to happen because the user in the database would have been test@test.com. So we're just gonna do @test.test.com and login successful, right? Let's just put in the wrong password. Email and password does not match. Any questions up until now? Cool. I'll take that as a no. So let's just make this a little bit more real world scenario, right? So let's change this. And let's say instead of a user, it's going to return a user. And in user, we're also going to say access token. We're just going to make this a little bit more and we're gonna say token is, and all of these, we're gonna make them required. So no, actually not required. We're just gonna leave them as that. Just that, all right. We're not gonna make, yes, we're gonna tell it to, it's always gonna return something. Let's head back to a resolver. And now in the return value, we're gonna return fake email. So email is fake email from DB. Password, we actually don't want to return password. That's a security flaw. So we're just going to return the email and the access token. And then we're just going to make up a token, right? We're just going to say access token and we're just whatever, right? So if this compiles well, which it should, we're going to go back to, so all we did was we changed the GraphQL query to return a user object. And we're saying that that user object can be either string or access token. Then we went to a resolver and we changed the return value from being a string to returning this, right? So now we're just, as it is, we're just gonna hit this, right? And it's gonna say, hey, field logging of type user must have a selection of subfields. That means that now we have to destructure what we want back. So we're gonna say email and access token. And there's your return value. But guess what? If this was HTTP, we would have to return everything. But because this is not HTTP, what if in one query, we just want to return the email because that's all we want? We could do that. What if we just want to return the access token? We could do that. What if we want to return the first name, the last name, or we want to return all? We can do that. So you could use the same query. Let's say if one query just returns a huge object with a lot of types, you can, in your client, use the same query and just ask for different return values. So you can already start seeing the power of GraphQL and the flexibility that it can give you, right? So at this point, we've already essentially completed the API, the GraphQL. So head back to your terminal. And if you recall earlier, and it's in the chat, I added the GitHub. We cloned our project from last time. And we're gonna go back to our directory. It should be workshop 2020 React. I'm gonna change directory into that. And we're gonna open this. I'm gonna bring it here into site. And the first thing we're gonna do whenever you clone a project, right? You don't know what's changed in that project. So I'm just gonna do npm install. And the only difference that we didn't do last time, so if you were in my testing workshop, we did a logging form. I just copied that logging form over here because I thought it was gonna be really useful in order to test our stuff, right? So this logging form, essentially, what it's a very bare bones, using a little bit of styled components. Clearly, I'm a fan. We're gonna have a small invalidate. Oops, I think that, okay. We're gonna have an invalidate, which is just imagine as the strongest validator every time, right? And which is gonna check if we have the @ sign. Then we're gonna have a piece of state. We're gonna save our logging input, and that's either gonna be the email or password. Then we're gonna have an onFormits form with an onSubmit, which we're gonna pass it through here, right? So while this is installing, we're gonna head over to our directory, and inside our source folder, we're gonna create a new folder called GraphQL, right? Inside this folder, we're gonna create a file called client.js. And by no means you have to do it here. I do it here because I don't know, I've kind of I've liked this, just a pattern I've used. And first thing we're gonna do is we're gonna say import up. Oh, we haven't started that. That's because we need to install a few dependencies. So while this is installing, I guess we'll just do export constant client. And this client is going to be a function. We're just going to leave it at that for right now. Now that this is done installing, we're going to go to our console here in the React project, and we're going to install a few packages. One of them is called Apollo-Boost. The other one is called GraphQL. And the third one is called @Apollo /React Hooks, yup, you heard that right. We're gonna use hooks here. Apollo brings hooks right out of the box, and they're game changer, in my opinion. And you're gonna see why. So Apollo Boost, by the way, Apollo Boost, so you have two ways of doing Apollo. You can import or install the Apollo client by itself, but usually, and we could have gotten away with that actually. So because we're not gonna really use anything else from Apollo Boost, but essentially Apollo Boost brings a bunch of stuff out of the a bunch of things out of the box. But we're gonna do import Apollo client from Apollo Boost. And then just delete this curly brace that we have here. And we're gonna say new Apollo client. And we're gonna open a function here. We're gonna pass it, open an object, press enter. Then the first thing we're just gonna do URI. And here we're just gonna do HTTP colon / local host 4000 / GraphQL, right? Because if you recall, we did GraphQL. So this is the minimum required signature that you're gonna need really to start. And actually, you know what? We don't need this to make this a function. I'm just gonna call new Apollo client there. Simple. Again, we imported Apollo client from Apollo Boost. By the way, you could have done just Apollo. That would be fine. Then we're gonna do, sorry, Nico, did you have a question? I think you posted something in the chat. Okay, guess not. We're gonna go to the index file and we're gonna say import, and we're gonna do curly braces here. We're gonna say from Apollo React hooks, and we're gonna import Apollo provider, right? Very similar to Apollo hooks. To React context, right? Then we're also gonna import our client. We're gonna say import client from GraphQL, from GraphQL / client. And now here, we're gonna press enter. We're gonna press enter right before the comma. And then we're gonna wrap here. We're gonna say Apollo provider. Now, Apollo provider takes client, and you might have guessed that client is the one we initialized in the previous one, in the previous file. Now we're just gonna wrap Apollo provider around app. And just like that, now everything that is within app is gonna have access to the Apollo provider. Just like context, literally, think of this like context. If you're gonna call an Apollo query outside anything that's wrapped by Apollo provider, is just gonna give you an error, okay? So we're gonna say app.js. Now we have this wrapped here, cool. We're gonna go to a GraphQL folder again. And inside our GraphQL folder, we're gonna do something called query.js. And for mutations, we would do one called mutation.js. And here we're gonna import something else from Apollo Boost, And that's the cool reason, right? If we wouldn't done Apollo Boost, we would have had to do Apollo client and GraphQL tag. We would have had to import very different packages, but Apollo Boost brings them all out of the box. GQL, very similar to the one we used in our Apollo server, right? And here we're gonna say export constant. And then because it is a constant, usually we name this with uppercase. And we're gonna say GQL, open the template, the syntax here. And in here, we're gonna say query, login, and we're gonna say $email is gonna be of type string, which is gonna be required, and $password is gonna be of type string, which is gonna be required. And we're gonna open a curly brace here, and we're gonna again write login, and we're gonna say email is of type email, and password is of type $password, right? So essentially, we're gonna map this. Oh, I wrote this as const. This is const. We're gonna map this So we're gonna, it's just mapping that email is gonna be of type $. This is the way it's written. Never really delved into why it's written that way. It's just the way it is. And then this is gonna return to us type user, which is gonna either be the email and the access token. So, and this is how in the client, we basically write out our queries, right? This would be, I guess, the equivalent of doing the Axios call or the fetch call, right? So now we've initialized our client, we've written our first query. Let's head back to our app.js. And in our app.js, right, what we're gonna do is, first things first, we are going to say const, then we're gonna open an array here, and we're gonna do equal, then start typing use lazy query. And this is gonna give you an option to auto import it from Apollo React. And if we go to our top file, you'll see that it auto imported. So VS Code will detect this and it will auto import it. And then we're gonna say, we're gonna open the parentheses, and now we're gonna start typing uppercase login. Same, it's gonna detect that there's a constant somewhere in the directory called login. It's gonna import it for us, and it's even gonna get the path right and everything, right? So it's something it's something less that we have to worry about. And then in here, we're gonna call whatever we called it, right? So login. So now let's uncomment the login here. And we're gonna do something. We're going to grab here this function, and we're gonna wrap it around curly braces. So we're gonna make it a multi-line function, right? And now I'm gonna grab the whole object that's here, right? And I'm gonna cut it out, and I'm just gonna do E. And now I'm gonna do E.prevent default. And I don't know why I've never been able to destructure default, prevent default before. I think it might not be destructurable. So just now I'm gonna create a constant. The contents that you cut it out, just gonna paste them here. So we're just gonna destructure from E, and just like that, it's just gonna go back, right? So this literally was exactly what I copied in this line before. Now we're gonna hit save, and we're gonna go to our server, and we're gonna do npm run dev in our terminal. This should bring the login form. And there it is, nice. Let's see what happens. So let's right click and inspect. And let's see, there's no errors in the console, no errors related at least to the network. Let's go to the network tab. And now we're gonna write here test. And we're gonna write test here. And first of all, it's gonna say 400. If you recall, 400 means it's our error. We fucked up, right? So we're gonna see variable email is required of type string. So it'll even tell you in the network what's missing. Hey, email of type string is required and password is required. But that's right, we never passed it through here. So we can do it one of two ways. You can either pass it as an, and we'll do it here just because we don't need to do it. We're gonna pass a comma in the use lazy query. We're gonna open an object, and we're gonna press enter, and then we're gonna say variables. And it's gonna autocomplete it for us. It's gonna give us the IntelliSense. Then that's gonna be another object, and we're gonna say email. We're gonna say form data. So form data, our state, dot email. Then we're gonna say password. We're gonna say form data dot password, right? So what's happening here is that in the input, when the change listener that we have for the handle on change and the handle on change for the password input, right? All it's doing is, all right, it's grabbing the name, which is gonna be this, and that's gonna be the key of the object. So if it's email, it's gonna be email, and then it's setting the value of whatever is in that input, right? So essentially we're gonna, when we type in both our email and our password, this is gonna have a key of email and password, right? So this is saved. Let's go back to our terminal and let's hit submit again. And cool. And it says errors. test user does not exist. Of course it does not exist, right? That is the wrong email. Even this is saying email is not valid. So we're gonna add test.test.com. Gonna clear this. There is something going on there. We're gonna have to do it, and then we're gonna hit submit. Oops. What's going on here? I think I'm firing off. Let me go back to the code, and we're gonna say handle.prevent default. And do I have a typo here? Nope. Okay. Cool. So test, and then test, and then we hit submit. There we go. And there it goes. Our data's right there. We have the access token, we have the email. So now we've literally come full circle. We built the React app at the beginning, then we rebuilt the API today. We created a mock login, we connected it to our client, and now it's giving us back the information. Now all you have to do is do things like set the token, create the user, and whatnot, right? And that's pretty much it. We've actually came in under time, 15